higher is the interest rate risk. Okay? Anything that wasn't unclear on that? Okay. Now let's do this number 20. Uh, this company has 5.9% coupon bonds with 18 years to maturity, semi-annual, and currently sell for 106.32. What is the current yield? What is the YTM? And so on and so forth. In this case, we don't know the yield, so I'm going to make this green light again. Yield to maturity. So let's see. Assume face value of 100. It trades at 106.32. Coupon rate is 5.9. Semi-annual and 18 years to maturity. Okay. It automatically solves for the yield to maturity. Okay. Now, this also calculates the current yield. Current yield is basically, let me just write it down. Coupon rate times face value divided by price of bond. This is kind of similar to the dividend yield for stocks. And our template automatically calculates it for you. It also asks for the effective annual yield. The yield to maturity is an APR concept. Effective annual rate. Let me write the formula. One plus yield to maturity divided by uh, let's call this CF raised to the power where CF is coupon frequency. T is years to maturity. And this is calculated right here. Excel actually has a function called effect. If you don't know anything, type effect, Control A. It has two arguments. What Excel calls nominal rate is our yield to maturity. What Excel calls NPRY is our coupon frequency. Come on. Of course, if I express it as percentage, unless I'm horribly wrong, I should get the same answer. Okay. But important thing is this template automatically calculates the current yield and the effective annual rate once you know what the yield to maturity is. And we solve yield to maturity by being in solver mode, pick yield to maturity as your unknown, enter the price, face value, and other inputs. Was that clear? Okay, let's see if we have anything else we want to do from this chapter. Okay, I'm just gonna go over this uh, verbally. You found a 10% coupon bond on the market that sells for par value. What is the maturity of this bond? Do you have any answer for that by any chance? If a bond is selling for par value, it could be of any maturity, whether it's a 1 year bond or a 1,000 year bond. If it's selling at par value, if that's the only thing you know, you cannot figure out what the maturity is. We didn't talk about this holding period yield thing anyway. So that's pretty much all I'm gonna say on this chapter. You guys want to do some chapter 9 problems, dividend growth model? Okay. First, let's do some basic stuff. All right. For this, we're going to use our dividend growth model template. Okay. On this one, I always keep it in the green mode. Yeah, I develop these things at different times. So if you're trying to get the value, just pick your market value as your unknown. This company just paid a dividend of 365 per share on its stock. The dividends are expected to grow at a constant rate of 4% per year indefinitely. Required rate of return is 10.5%. What is the current price? Now, this template allows for different number of known dividends. Okay. And the inputs are required rate of return, which is 10.5%. So-called terminal growth. What's the growth rate after the first year's? It's what, 4%. In this case, the only thing I need to do is write the year one dividend. But be careful on this problem. You know the year zero dividend, but you also know that that's going to grow by 4%, right? So I'm going to actually write this as 365 times 1 plus 4%. You could also write times 1.04, but I kind of find this less error prone. You don't have to worry about the decimal version of 1 plus something percent. So next year's dividend is going to be 380. Well, given that, that's the value of the what you want to call stock. Okay, this is basically what we call. I think we called it case one or model one. You have, you know, the first year dividend, and you also know that dividends are going to increase at a constant rate after that indefinitely. This is all you need to do. Let's look at the rest of the problem. It says, what will the price be in 3 years? Okay. Now, the nice thing about this constant growth is 3 years from now, dividends are still growing at 4%, right? So if I'm pricing this at the end of year three, that means the price is going to be based on year four dividend and the growth. But year four dividends, in this case, I'm going to grow it by 4 years. No, yeah, 4 years. Three years. Yeah, because dividend at years t plus 3, t plus 4, I'm sorry. Dividend at year 4. Dividend at year 0 times 1 plus the growth rate raised to the power 4. Okay? I mean, I'm doing it with formula in the Excel, but we could also do it here. 365 times 1 plus 4%. Surprise, surprise, we have exactly the same answer here. Okay. So 3 years from now, this stock actually is going to go up in value. How about 15 years? This time I'm going to grow it for 15 years. No, 16 years. I'm sorry. Because I'm trying to figure out year 16 dividends and so on and so forth. So in general, if a firm has a constant dividend growth rate, you actually expect the price of that stock to grow at that rate as well. So that's your capital gains rate in a sense, because it keeps giving you higher and higher cash flows. Let's do another one. This is a little bit easier. Now the problem tells you what next dividend is going to be. That's 193. Okay. 4.3% growth. If the stock currently sells for $41 per share, what is the required return? All right. Let me see. 4.3.